operators. So means operating on true or false. Okay, so for an AND operator, both statements must be true, or all statements must be true, so that the value will be true. Okay, so true and true, that is the requirement, and true. Okay, just need to add an and, another and. Okay, and all statements must be true, so that the value will be true. If one of them is false, the statement is already false. Okay, and it's commutative. No? Doesn't matter if it's the first statement, the second, third statement that's false, the total value of the statement is already false. Okay, of course, false, false, false will give you a false statement. Okay, for the or, you just need to have one true to make the whole statement true. Okay, let's replace and with an or. Alright, so you only need one true. So of course if you have two trues, then the statement's still true. Okay, it's commutative. Okay, this one statement is true, is needed. For the not, you just need to, it will just negate the logical value of the argument inside. So not true is definitely false. Not false is true. Okay. Now we can have a complex logical operation. Not true and false, okay, will give us true. Okay, because true and false is false. Not false is true. Okay, so you can play with it. True and false, or true. What will be the final value of this statement? It will be true because you have an or here, and you only need one true to make the whole statement true. Okay. But let's say you have a statement like false and false, and then false, and then you add a parenthesis, something like this. False or true is false. False or true is true, but false and true is false. Alright, so and those logical values can be derived from expressions that we described in the earlier video. Okay? So let's say we assign some values here. Alright. By the way, integers, okay, or non-zeros has a logical value of true. So not true is false, while 0 has a logical value of false. So not 0 is true. Okay, let's proceed. So we have, let's say, is x greater than y, and of course the value of this is false, and then we have an n, so that will be, let's say, y is less than x. So definitely one of them must be must be false, and one of them is true. Okay, so you get a false since one of them is false. But if you use an or operator, okay, it becomes a false. Let's see, x greater than y, 3 is greater than false, is y less than x. Oh, okay, sorry, it should be y, should be x less than y. Alright, so that will be true. So that a while ago it's actually the same thing. So let's go back. X greater than y is false, no? Because this one is false, and the second expression is true. Okay? Alright. And then you can use the not operator here. If you want, then you'll have the true value. Okay, so let's say we want to check if x is between a certain range. So let's say x max is equal to 10, and then we have x min is equal to 2. Let's make it simpler. X max, x min is equal from 0 to 10, something like that. So you can use this expression for assignments. So x mean should be smaller than x, okay, and x should be smaller than x max, so that we know it's between or within. So x mean is 0, so 0 is less than or equal to 3, that's 2, and x is 3 less than or equal to 10, so that's also true. Okay, so if I make this, let's say x is equal to 11, of course that will make the statement false. So that's how you can use logical operators